You're at a concert for your favorite band. The music is loud, fast, and groovy. Hearing that music may seem so ordinary and nonchalant, but in reality, a ton of things are happening in order for you to hear that awesome guitar solo, and they all happen in the blink of an eye. Or, in this case, an ear. First, sound waves enter the outer ear, the part that sticks out, by way of the pinna, the visible surface of the outer ear. The good vibrations then travel through the auditory canal, the tube that connects the outer ear with the middle ear, the chamber between the eardrum and the cochlea. Once in the middle ear, the sound waves hit the eardrum, a thin and tight membrane that vibrates when the waves hit. Once the vibrations pass through the eardrum, they go to the hammer, a tiny bone located in the middle ear. From there, the waves are passed to the anvil, another small bone in the middle ear, and finally to the stirrup, the smallest bone in the body, which passes the vibrations to the cochlea.
Once the waves hit the snail-shaped fluid-filled cochlea, it is in the inner ear. The motion disturbs the fluid in the cochlea and causes ripples in the thin strip of tissue in the cochlea called the basilar membrane. In the basilar membrane, there are tiny hairs that connect to the neurons. The hair cells behind, when hit with sound waves, cause a nerve impulse to form. The axons of the hair cells join to create the auditory nerve, which send the neural messages to the thalamus, which organizes sensory information in the brain. The thalamus then sends information to the auditory cortex in the temporal lobe, responsible for hearing and language processing. Say you're high up in the nosebleeds for the concert. Your eustachian tube, which connects the middle of your ear to the back of the nose, will equalize the pressure between the middle ear and the outside ear to keep you comfortable. With all those screaming fans jumping up and down, you can thank your semicircular canals for keeping you balanced throughout it all. These circular filled tubes loop around the attached cochlea and maintain our balance.